The broadcast is now starting. All attendees are in listen-only mode.
Welcome to the latest webinar sponsored by the new Workflow 4.0 e-newsletter and ClearEdge 3D. Our webinar topic today is Better, Faster As-Built BIMs, Case Studies and Best Practice Scan-to-Revit Workflows. My name is Kevin Corbley, and I'll be your moderator today. I'm the Editor-in-Chief of Workflow 4.0, the newsletter of 3D scanning, modeling, documentation, ideas, and opinions. First, let me start by thanking you, our attendees, for joining us today. We know we have a great topic. It's of great interest because this is by far our biggest turnout for a webinar. More than 500 people have registered to hear more about best practices for creating as-built BIMs, and we know you'll be pleased with what you'll learn in the next hour. Let's take a quick look at today's agenda. We have two professionals from the scanning and modeling industry who will be telling us about their recent BIM projects. One is a mechanical BIM at a transit authority facility, and the second is an architectural BIM at a bank headquarters building. And then we'll take a look at what's new in the Edgewise BIM suite releases coming this spring and summer. And as always, we'll let you in the audience send in your questions to our panel of experts. And a quick couple of housekeeping details here. Everyone in the audience will be muted during the session except the presenters. And feel free to ask questions via chat during the session. And we're going to actually take a couple of questions during the presentations, actually at the end of each of the first two presentations. And then the rest of the questions we'll save for the Q&A session at the end. So feel free to use that question box on the right-hand side of your screen to send us questions just any time you want. And a reminder, the webinar is being recorded, and each of you will receive a link at the end so you can go back and watch it again or send it to your colleagues. And also a reminder to subscribe to Workflow 4.0. That's the e-newsletter of learning and sharing experiences, opinions, and best practices. Before we get started, I want to introduce our panelists today. And first up is going to be Mike Pfaff. He's the HDS manager for Bowman Consulting. Currently based in Northern Virginia, Mike has a long background in scanning and surveying, as you see there. And then next, we're going to hear from Mark Hanna, the president of Precision Point, which is a company he founded just about 5 years ago in Carmel, Indiana. And Mark has a background in both engineering and surveying. And there on the far right, you see a familiar face to those of you who have joined us before. That's Kevin Williams. He's the chief scientist for ClearEdge 3D, and he'll be the one giving us a sneak peek at what to expect in the near future from our Edgewise BIM suite. Gentlemen, we're happy to have you all with us. And you're going to learn a lot today, and we always have a few key takeaways we like to let you know about in advance. You're going to learn how Precision Point and Bowman Consulting are integrating the latest tools, technologies, and processes into their workflows and project deliverables. And I think you'll see in detail how Mark and Mike planned and executed as-built BIM projects to ensure a happy client and an even happier bottom line. And through the case studies, you'll discover the latest techniques and tips our panelists used to speed their as-built workflows. And then, of course, you'll see what's coming next in the Edgewise BIM suite. And we always say context is king. So let's set the stage for today's webinar by providing some context that I think will resonate with many of you. The first point there, the BIM wave has arrived, and I think the attendance on today's webinar really proves that. A recent study showed that 70% of AEC firms have adopted it. In addition, more and more clients are demanding Revit deliverables for the infrastructure and renovation, and that delivering an as-built BIM can be costly, time-consuming, and full of unknowns, which greatly increases risk. And that's something I think all of you in the audience can attest to. And finally, firms that do as-built BIMs are in a difficult position balancing service and margin. And we're going to talk a little bit more about that today. So that being said, we are ready to get started. And Mike Pfaff of Bowman Consulting, I'm going to bring you on, and I would like you to go ahead and I'm going to hold on to the keyboard here, Mike, while you're talking. But please come on, turn on your microphone, and let's get started.
Okay, I'm here. You hear me okay?
Yeah, go ahead, Mike.
Okay. Well, briefly, Bowman Consulting, engineering firm, survey firm, first and foremost. We do quite a bit of work with civil planning, surveying, wastewater, energy, geothermal, mining, and transportation, land planning. We've been around we're based in the Virginia area, but we're pushing ourselves nationwide here. So we have presence in 19 offices, I think about 10 different states at this point. So I guess that's enough about Bowman. I kind of like to advance to the next slide.
Okay.
Our case study is based off the Washington Aerodrome Metro Transit Authority is in the works of doing energy assessment on a lot of their maintenance facilities. Some of them are in very old condition, and some of them are, LEED certified buildings. So they're trying to assess their overall facilities and get a grasp on where they are to spend the dollar in the proper place for bringing the efficiency of the building up to what would be considered current. When we went into this project, it was for the energy assessment model. They weren't really sure about how to integrate that scanning into that portion of it. We'd kind of worked with them on what tools were available for them to use. One of the more interesting things was the ability for us to integrate photographs into the BIM model via hyperlinks. Our VZ400 allows us to capture photographs, and it has a flash on it. So when you put it in the plenum spaces, you can get a good idea past just what the point cloud has to offer as far as what's actually happening in the plenum spaces. So I've kind of covered the images acquisition for the MEP identification. That's the image to the right is the model of the building after it's been through the BIM process. They also were wanting to put the semblance of the building on their GIS, so when they move through with this, each of these BIM models would be in a kind of a DWG format existing in their GIS world for kind of general planning on overall site. That kind of made an interesting problem because each one of these buildings now has to have a local translation set up through the GIS control network. So we had to do a little bit of planning on trying to figure out how we were going to get each one of these facilities truncated into an environment where the rotation and everything else was consistent with what the control had said it was, and then being able to model it and move it once it was modeled into a GIS world and maintain that orientation in the correct position. The MEP creation was something that they weren't quite had a good grasp on, so we helped them identify the pipes using the Edgewise software for size. Some of the metadata they wanted tagged onto what pipe, the type of pipe it was, the size, whether it had any of the insulation and things of that nature on it. So that's kind of where we got the advantage of having the camera on top of there. We can physically kind of see what's going on with the pipe. They also were wanting to come up with a QC documentation plan that would be instituted for all these BIM projects. So we came up with a method of taking reflectorless check shots on the facility as we're running our traverse through there, and then doing a local comparison to the cloud to see, where that control shot fit in and whether we had, how big the data set was with the overlap of the scans at that point in time. So I'm ready for the next slide. They also had a couple other issues. To be kind of, it's a busy facility, and this is actually done in the winter, and these, depending on the snow conditions, it can get to be quite a busy facility. So we're trying to keep our presence in a low-impact environment so we weren't spreading ourselves throughout the facility in different phases of this. The other problem with that is maintaining control on the site during the scanning operations. It's all well and good to think that a person is going to put a control point down, but whether it's going to be there 2 days later, especially in a facility that's muddy boots and everything else going on across the floors, we had to come up with a reliable system to maintain the control during our operations there. Another challenge that we experienced is the plenum space access and developing a way to register the plenum space information in relation to the point cloud data that was collected locally on the ground. Another issue that we had was, like I said, developing the site control versus the Revit system that can be done with shared coordinates inside Revit. Most people, I think, are aware of that, but it's the tool that allows you to work on multiple coordinate systems as long as you have a chosen point of origin where you can modify the coordinate values for each of the different disciplines involved. Would be like civil engineering and the MEP folks and things of that nature. And then the other ultimate challenge is helping the client understand the expectations versus reality. I know a lot of times the client seems to think these are X-ray machines, and that's not necessarily the case. So we had to stage things so they understood what they were going to get at the end of the day from their model, as opposed to kind of what folklore says about it as far as laser scanning goes. So our field workflow, then we elected to use like a robotic total station. It has excellent reflectorless abilities. We used the Topcon GRS-5 for GPS to bring in local control for traverse activities on the site. We used the Regal VZ400 with the Nikon D400 camera mount on top. That's what allowed us to capture the photos up in the dark areas of the plenum spaces. And then we used a Moog Hercules tripod with elevator that's shown in that image. It's a very stable tripod. It does a very good job as far as getting you into areas that are hard to get at as far as plenum spaces. I recommend it highly. So the GPS control baseline was set, and then we traversed around the exterior. We also traversed through the interior of the building, setting control and scanning in unison. This allowed us to impact area locally, only for the time that it took the scan to be taken. So that expedited our workflow. So on to the next slide, please. So the field workflow was that we were to take total station reflectorless shots, and we were going to QC them on the registered point cloud data as far as our QC step, and then put a report together for WMATA on about 25 locations across the building to verify consistency of the data. We also instituted a tilt mount on our MOG tripod there to capture the areas that had restricted access vertically in the plenum spaces. That being that there was maybe only a foot or so to put the scanner up in there or less than that. So in that regard, we would remove the tiles and scan the information from the ground level. In the areas where we didn't have that vertical constraint in the plenum spaces, we'd stick the scanner up inside the plenum spaces and then register our data to the cloud information that was below. And down there you can see the image of the camera on that last slide, kind of what the outcome was for the panoramics that were made. As far as the operations and getting the project done, we elected to have 3 people on site. 1 man for operating the traverse control and doing the planning that way. 1 man to keep the laser scanner moving at all times. And then another man to go and do an assessment of what was happening with the plenum spaces, whether we need to remove tiles, identify routes, locations where the routes were changing, and make sure we had those tiles off so that we could document some of the areas that had those vertical restrictions on it. The key to having 3 guys on site and working well is to make sure you guys have radios. Saves a lot of time when you're having to walk back and forth and check with other people in different rooms. If you just have radios, you can kind of relay intentions or conditions back to the field chief more effectively. That helped quite a bit. And again, it's when you get in the MEP stuff, doing a kind of a mission planning prior to the scanning, getting to the locations is kind of critical as far as I see it. You have to be able to go up there, and you don't want that scanner not scanning. So as long as you're taking a look at what the route is beforehand, things seem to go well, and you have a better result when you get back to the office. And then always keep the place tidy. I know it's there was a lot of work getting those tiles on and off, but we kept everything organized and out of the way, and they were quite happy with that. So I'm ready for the next slide. So as far as the modeling workflow, phase 1 was, of course, to process our GPS and traverse control and do any adjustments that were required there. Phase 2 then will be the registration of the point cloud data to the finalized control network. And then we made our panoramic photos at that point and put coordinate values on them so that they could be hyperlinked into the Revit model. Phase 3 would be prepping for the cloud-to-cloud registration. When I say we're doing cloud-to-cloud registration, we're doing a controlled network of cloud down on the floor spaces, and then using those clouds to register data up to the plenum space. Regal has a very good cloud-to-cloud package that allows us to do that. I know some of the other scanning softwares are not so helpful in the cloud-to-cloud registration. So that's something that was kind of unique to a Regal software process. And then the final, the final export goes out to our Revit modelers. We try to keep all our scans ununified as a cloud package. That being that we export each cloud separate. Revit has a tendency to decimate the clouds, and you don't have much control over that. So the more data you give into the Revit cloud, the better you are with negating decimation issues with the data in Revit. Phase 5 then would be QC of the cloud data against the conventional QC shots. And then we'll put a report together for them on that. Phase 6 then will be the Revit model production using HYs, MEP, and actually used two aspects of that modeling software for this. One was for the pipe abstraction itself, and then the other was for meshing the floors. They were irregular floors for local drainage in there, so we used that to get the mesh data for entering into Revit for the floor types. And then we used a 3D reshaper to modify the floors and reassign points to the mesh. That was the final import into Revit for irregular floors. That's kind of a beast inside Revit to get accomplished. So the final deliverable was QC document. That was our documentation. We used TopoDot, RiScan, and TopCon to deliver the overall results for our control network against the cloud data. The registration documentation was done through RiScan. The Revit and PCG export cloud with panoramic images were hyperlinked into the Revit model. And then we exported out our DWG in the for the transformation onto the GIS coordinate system. And then we maintained those hyperlinks for the images in that model as well. The client markups and revisions, we limited them to 2 revisions. That's something that definitely saves you time. You don't want to give them the opportunity to review things 10 times. So we stated that very clearly in the contract. And then we handed everything over to them. As far as the as-built and BIM tips and tactics, control establishment at the time of the scanning is a real time saver, and it allows you to kind of keep everything independent. Once you're in one site, you know, everything's done. The controls been laid, the scans have been collected, and you can you know, pretty much pull all your targets down at that point in time. It saves a lot of time for one, keeps the sanctity of your targets good at that point. The control shots ensure awareness of possible registration issues. Like I said, you always have to QC your clouds. Even though the registration comes out good, a visual inspection is paramount. Planning adequate staff and proper communication with the client, technical knowledge of equipment, make a happy client and a happy project manager. Again, planning. It's well worth the time spent to have a good game plan before you go out on site and have the people trained appropriately, or you can make a big mess out of a small project. And then again, limit your client to the opportunities they have to critique the model. I know that we've ourselves have suffered that quite a bit, where it's the clients just kind of they just keep coming back, and then so you got to kind of limit their opportunities to do that to, you know, revision or 2. I think that's it for this slide. Be creative in your integrated checks. There's a lot of different tools inside the software. Make sure that you're knowledgeable about all the tools that are available in your software. A lot of software has things in there that you know, if you don't explore, you don't find them, or can be adapted in different ways. Always make sure that you have your game plan for the BIM model clear with the architects involved, so that you're not having to rotate and translate things after the project has been executed. And a lot of Revit families are inconducive to being moved once they've been placed. Site visit on the plan of projects is critical. I know that's not always possible, but it can get very, very expensive if you're not aware of how much MEP that you're walking into on your model. Again, be very specific in your contract as to the performance, what's to be modeled, pipe sizes, whether you're going to be doing conduit or not. Those sort of things can really help keep any adverse comments and conditions coming back from the client. You don't have to have any friction if it's not necessary. And be clear on what level of detail that you're going to be modeling in your contract. If you're not aware of it, AIA has different levels of detail for scanning. I think that's it for this slide. And thank you for your time.
Okay, terrific, Mike. Well, you've already got several questions coming in from the audience. I'm going to throw one at you right now. Somebody asked an interesting question. What was your solution for maintaining control points when scanning occupied spaces over several days?
Well, some of that is a matter of duct tape.
Okay.
Duct tape and cones. A lot of times we'll take cones and we'll talk to the maintenance staff beforehand and leave little small cones on where the control points are so that they know not to polish over them. Regal sells these small stickers for their retroflective targets. They also actually work quite good for maintaining traverse control on the floors. So we utilize that and then duct tape and the cones to kind of maintain our traverse control.
Okay, that's great. All right, well, we're going to have several more questions for you at the end during the Q&A, but right now what I'd like to do is bring on Mark Hanna of Precision Point. And Mark, I'm going to hand over the keyboard so you can go ahead and flip through your own slides.
All right, well, thank you, Kevin, and it's a pleasure to be here today. We'll tell you a little bit about who we are and our presence in the laser scanning industry. As Kevin indicated earlier, the company was formed in 2009. We are a 3D scanning solution-centric company. We specialize and focus on 3D scanning solutions kind of from end to end, if you will. Quite experienced at this time. We've completed over 200 scan projects nationwide. Those consist of small projects to very, very large projects. Last year we completed a 1 million square foot facility, which was quite an accomplishment for us. We are, like most service providers, all of us kind of specialize in certain areas, and for us, we're scan-to-BIM specialists for architecture, MEP, preservation, industrial factory, and we have a special niche in the material handling industry and applications that would include parcel packages and baggage handling systems. And rounding out our 3D scan services, we are doing more now in 3D construction coordination with our contractor clients. We're also a FARO authorized reseller. We offer scanner rentals, and we're very, very proud to also be a clear edge reseller. Not only are we avid users of these products, but we believe them so much that we help convert most of some of our scanning clients get these software tools in their hands. So the project, our case study, was a little bit of a unique project for us. What made it unique, not a terribly large project, but we were approached by a financial institution that was looking to move from 2D to 3D, and in particular, they wanted a 3D model of their headquarter office, which also had an adjoining branch office as well. And the reason for their interest in a 3D asset model was it would serve a couple purposes, but the primary purpose would be for emergency preparedness procedures, developing a evacuation procedures for both man-made and natural disasters. So ultimately, it was really for personnel and data protection as well as asset documentation. And all about a 30,000 square foot facility. But what made this one a little unique, and we'll share this with you in a second, is it had a rather compartmentalized interior space. And then the final deliverable for this would be 2 deliverables, a Revit, SketchUp, and a SketchUp deliverable as well. Looks like our scan. Okay. So this project posed some unique challenges. As they indicated, it was a compartmentalized facility, and we'll see that here in a second. But what also made it unique was it was since it was an operational office building with some high security assets in there, all the scanning had to be done after hours and over the weekends. And our scan crew was under 100% security for obvious reasons. And lastly, we the company and the staff on site had to go through criminal background checks. So as you can imagine, that was completely understandable for a project with some sensitive data in there. So it was for us, it was kind of an interesting endeavor to go through. It took a lot of time to even get to the point of doing the actual scanning. So as you can imagine, being in an environment like this, planning was essential. The scanning was determined it would be completed over 3 weekend days, and we needed to coordinate all of the scan locations, so we had to develop a pretty detailed scan location map. This was then cascaded throughout the organization, so they knew precisely when we were going to be there, at which time, so that any secure documents could be secured and put out of sight, because it is an imaging tool, so there were items that they didn't want picked up in the scan data for obvious reasons. And in particular, we had very narrow windows of time to scan in high security areas, most notably the vault and the IT areas. So so the planning was really essential for this project. So our field collection then, we utilized a Faro Focus 3D scanner for this. In all, it was a little over 200 scans to do the entire interior. We also did the exterior as well. It was interesting. There was a question earlier with Mike's presentation relative to how to reestablish targets. We've developed our own stickers, which are used in conjunction with our spheres, and those are pretty important on this project because we came back over 3 different times, and then since we couldn't scan the facility at one time and flow freely through the space, it was really essential that we could reestablish our targeting, couldn't rely on overlapping scans. And then lastly, of course, we did establish a small survey control network, which was utilized to verify our final scan alignment. So back at our office, then we started the process of completing the scan registration. We use Ferrocene software for this process. For those of you who haven't used Ferrocene, they've got a pretty robust auto-targeting feature which goes through the scan data and acquires the sphere targets automatically. That really shortens the registration process. So we were able to, for this project, to scan or to register everything in just under 4 hours. So that's when you pre-process everything the night before, acquire the targets, the technician can just focus his time getting all those scans registered. So we had 1 technician, and then for staffing of the modeling, which I'll go into shortly here, we had 2 staff BIM modelers working on that. Once the scan was registered, It was QC'd fit and alignment, and of course that was done against our survey control. That's obviously an essential step before we start any modeling to ensure that we're beginning our modeling from an accurate and accurately aligned point cloud data set. So moving on now into the modeling workflow. So again, using Edgewise Building, and this was our first. We demoed the software and beta tested it, but this was our first real project where we really felt we had a good candidate for really running the software to task. So the first step was to take the individual Faro scans and process them into a single unified point cloud shown here. So we batched everything and then ran that process to start the unification in Edgewise. We did this in 2 passes. The first pass was initially for just the interior point clouds, and then we made a second pass of the exteriors, and the purpose for that was to remove the possibility for any false positives from the ground surfaces. And that's actually a recommended workflow as well for this, using this tool. So once the unified point cloud was finished processing, we were now ready to begin the plane extraction, and this is the prior step to the wall extraction. Again, this is a batch process. It can take a couple minutes per scan. So what we did is we queued all the scans and ran them the night before. So the following morning, we got to this stage here, where all the planes were extracted. Now, at this stage, it's really important here to thinking the end result is a Revit model. At this stage, the next thing we need to do is create the plane extraction, and what I'm showing in this illustration. So these are the levels that commensurate with the levels in Revit. We establish one on the lowest floor, and then another at the ceiling, and then you would continue that process on every floor or every level throughout the building as they exist. And again, this will ensure that the walls begin and terminate at their correct locations. So this is kind of an important step. Really simple in the software, though. Once we're at that stage, we can now initiate the wall extraction command. And this is really where the magic happens, for lack of a better term. Now at this stage, the walls are extracted, as you can see in that upper image. Again, we're still in the Edgewise environment, and at this stage, it's very, very easy and simple to go through the walls and look for any false positives. For instance, open doors. Sometimes we'll create a small wall. It's real easy to select and delete that, so a modeler can quickly go through the walls and determine what should be there and what shouldn't. Occasionally, a wall might be missed in the feature extraction. It's real easy to select those points in the point cloud, turn that back on inside Edgewise, and then do an extraction for that wall. And then at this stage, it's really best to go through and do your final QCing before you get into Revit. Make sure all the corners are connected. There's nothing missing. Spend a little bit of time here to make sure that everything seems to make sense and the walls are all there. Now at this stage, we can then begin the export command. So what will happen here is Edgewise will then export an RVT file. And at this stage, then we can move into Revit. And inside Revit, there is actually an Edgewise tab in the main Revit window, which you can utilize now to actually open the project just like you're opening any Revit project. Now at this stage, you'll have an option to change a few things. In particular, it gives you, before the walls are brought into the Revit project, you can select a tolerance. For this project, we selected an 1/8" tolerance, but it's important to stay within the Revit units here, otherwise it's not going to be successful. And then the end result is the lower image there, where the walls are brought in inside the Revit project. And again, those are generic Revit wall families. And then at this stage here, there's also some options. For this project, all the wall families were brought in planar and perpendicular. That was how the client wanted them. But you also have the option of orienting the walls as built as well, which is a really nice feature. So you can actually, instead of best fitting the walls to the point cloud and keeping everything planar and plumb, you can also, maybe for construction application, have the wall plane or face built exactly on the point cloud. So that's a real nice value add as well. So getting to our final deliverable then, as you saw on the previous slide, our starting point for the model was almost an entire set of walls. So that translates into real savings, roughly about, our modeling was reduced by, we estimated about two-thirds. And we also moved forward with much more confidence that since we're using the point cloud itself to position the walls, we had high confidence that those walls were placed in the right location inside the model. And again, we further QC'd inside of Revit. And then for a happy client, we were able to pass on some savings to the client as well. So moving into some tips and tactics, not only for the project I just demonstrated, but also for all scanning projects. For those service providers or owners looking to enter into using scanning and modeling for your projects, it really starts with communication and pre-planning. Mike mentioned that earlier in his presentation. And when you're inside of a client's facility, knowing where your crews are going to be is really vital. We like to create a scan location map if possible. That helps with the proposal preparation and costing for the project, but it also is a nice tool to use and give to the client so they know where you're going to be in your facility. That's pretty helpful. And then along with that, publish a scanning schedule. And again, that's really to minimize any client disruptions. We also find that having an on-site contact for building access issues is pretty important, in particular for this project. Undoubtedly, any scanning project, you're going to need access to a particular room, and you need to know who to call because time is money, and there's a scan crew waiting to get in the room, and then that's not good for anybody. And then, most importantly, as in the prior presentation, in buildings, MEP and structure is just as critical as the walls. So try to understand those considerations with your clients prior. We do quite a bit of above ceiling tile plenum scanning, similar to what Mike did, and try to understand that at the beginning, what you're getting yourself into. He had some really great points that I concur with completely. And then, for us, we still rely on verifying our scan registrations using survey control. For us, it's not a difficult step, and it gives us confidence that we're providing engineer and design grade point clouds, not only when we model in-house or when we're just providing point clouds to our clients. We have the confidence knowing that that point cloud is accurate within the tolerances. So we're big believers in using survey control along with our scanning operations. Try to obtain record drawings for your project, although we're not using them to create the model per se. We are using, there's good data inside those as well relative to MEP pipe sizes and whatnot, and I think that's, so it's a good reference for your modelers to have that as well. And then last, relative to your BIM deliverable, your level of development in your model, this is really a big area. This is a challenge for us in the scanning industry, likely others. Really work with your clients to help develop that level of development for that final model. As Mike indicated earlier, there's a lot, the scanner picks everything up. So what do you want translated in that deliverable is really essential. Same thing for owners. Try to communicate that to your scanning service providers so that you're going forward with a project understanding what that final deliverable, BIM deliverable is going to be. So I've included a couple of references here. The BIM forum's got a really helpful level of development specification from August. And then if some of you aren't aware of the U.S. Institute of Building Documentation, which I'm a board member of, as well as a member, that's another great resource for helping develop those LOD standards. So I highly encourage you to check that out if you weren't aware of those. And then another really good tip is sometimes our clients come to us with a Revit model that maybe was started from plans. So there's if that's the case, we like to georeference our scans to any existing model so that we can, when we turn our point clouds over to our clients, if they're getting that point cloud data, everything's all aligned to their existing models. So I think that's a great question to ask. And then lastly, if your client has already developed Revit templates, please ask for them if you're a service provider, or provide those if you're an owner to your service provider. It's really beneficial to, we'll use your families when possible and really get you a deliverable that's going to meet your requirements. And that completes my portion. Thank you.
Okay, great, Mark. Hey, thanks a lot. I appreciate that. And, you went through so many different facets of this particular project. If you could isolate where you think the greatest time savings was for you, what would you say?
For this one, it was undoubtedly the modeling. The wall extraction really gave us an advantage in that we were starting from a nearly complete wall set in the model. So instead of starting in a blank Revit project, we started from something that was at least two-thirds of the way done in our view. So that's what made this project successful.
Okay, terrific. All right. Well, what we're going to do now is we're going to move on to Kevin Williams. And Kevin's going to come on and tell us a few things about what we have to look forward to in the future. Kevin? Kevin, can you unmute yourself?
There we go. Yeah, can you hear me now?
Yep.
Okay.
Gotcha.
Okay. Fantastic. Thank you, Kevin Corbley. So what I wanted to do with just within the next couple of minutes is give you guys an overview of our technology development roadmap for the next 4 to 6 months. I know we have a lot of people that we work with who kind of plan out and spec their projects based on available technology and what's coming down the road. So the first thing that we're working on right now and expect to have a release out in the next couple of months is edgewise structure, and I'm really quite excited about it. We've had people asking for us to build this technology for several years now. And we haven't been able to for I guess 2 reasons. One, time and resources, but also we just didn't realize the challenge that the market actually faced. I kind of figured, how hard can it be to extract steel? But over the last several months, I've had the opportunity to sit down with a number of people actually modeling steel, and it's a pretty tedious process. And one that we're hoping to make a whole lot better with edgewise structure. So I'm excited about this. We had a couple of real technological breakthroughs in the last month or so, and we now have W sections, which I have discovered are I-beams. I'm starting to learn the technical speak for structural steel here. We have W sections working really quite well. You can see an image here. The software has gotten very robust for extracting those and nails the right cross-section the vast majority of the time. And we're porting that same technology this week to other types of steel cross-sections like T cross-sections, channels, steel tubes, things like that. And everything that we build in this structural steel module is entirely spec-driven. It's based with that as the core. But the good thing is you don't have to be a steel engineer to know all of the sizes in order to work with it. You don't. The software will figure out what size is supposed to go in the place. You don't have to specify it. And if you want to change it, you still don't have to know. We have developed a pretty intuitive graphical interface to resize these and get the size of steel that you're looking for without having to know the exact AISC standard name for it. We're also we're building this on top of the Smartsheet QA technology that has been present in earlier versions of the piping software in particular. So that's a really quick and easy way to go through and validate every single piece of steel that's extracted here. Our initial exports, right now we are capable of exporting to AutoCAD, MicroStation, and Cyclone. And in the next couple of months, we're going to finish out the Revit as well as the PDMS exports that we can export to the same format so we can export the pipes to. Kevin, can you move to the next slide for me? So that's edgewise structure. That's coming out here in the next couple of months. In the summer time frame, we're going to be adding on to our existing BIM suite. In the MEP arena, the most noticeable thing is going to be the extraction of square and rectangular ducts. Again, we've had a lot of people ask for this. And we're going to be able to leverage the same technology that we're using with structural steel to do this. Now all that's left is getting it to talk to Revit, which will be fun. And then we've also got a number of niceties and feature enhancements that we're going to be throwing in. Things like better clipping boxes, better selection tools. A biggie is going to be better QA integration with Revit. Similar to what we do with edgewise building, we want to be able to give that same type of functionality for pipes and ducts. And then on the building side of things, we're working on improved wall extraction to help with some of the issues that Mark was talking about, things like extracted doors. I think we can eliminate those. We can make it more robust for huge projects, which and just make the software work more applicable to more projects. We're also going to be releasing finally the door object recognition. We've had that somewhat working for a while now, but it wasn't quite up to our standards for what we thought it should be able to do. But we're improving that, and we'll be releasing that in its entirety this summer. And we're also going to be adding the ability to model floors and ceilings to kind of complete the major structures of a building. So that's what's coming in the next 4 to 6 months in terms of our technology development.
Okay, that's terrific, Kevin. Appreciate that. And, we are ready for the Q&A, and I can tell you right now we have so many questions in the queue that we're probably going to go about 5 minutes over. So I ask the audience to bear with us, and I'd like to ask the panelists to turn the mics back on. And Kevin Williams, why don't you take us through the Q&A?
All right, sure thing, Kevin. The first question that I've got is for Mike Path. And the question I have is, did the client define the level of required tolerance for the geometry in the model?
Yes, they did. They're looking at a 1/2 inch or less, which is one of the reasons we took the reflectorless shots throughout the facilities to identify and show the consistency of the cloud data against the traverse data.
Okay, okay. And Mark, what computer did you use for the process?
We're running more work now using Dell Precision laptops. So these are i7 latest generation processors, and it's an interesting question because edgewise, as well as a lot of the Autodesk products now, are actually much more efficient with point clouds. So we're finding that you don't need these really super high-end computers to process point clouds. We're finding that a mid to high range computer will do the job just fine with a good graphics card.
Yeah, that's kind of what we've been finding as well. Hey, another question for you, Mark. How did you get the Revit model to SketchUp, and what was the SketchUp model actually used for?
That's an interesting question. That was, we exported from Revit to AutoCAD 3D model, and then SketchUp then could then import in the AutoCAD 3D model. And then the reason the clients requested a SketchUp model was really more kind of ease of use inside in their organization, because the Revit model they were going to use more for any future designs with an architect later. But so the SketchUp model was really a way for them to use the model with an easy software.
Okay. This question looks like it's for me, and it's talking about the structural steel extraction, and the question was, does the structural steel extraction work with steel that has fireproof coating? And the answer is not yet. That's something that was just brought to our attention recently. So the algorithms work on clean steel very well. But we have an approach now to tackle that, and so that's something else that we're going to be working out over the next month or so before release of the software. And so we should have a very good workflow for working with fireproof coating by the time it's released. Mike Path, how did you deal with surveying in U.S. survey feet when Revit doesn't have that unit?
We dealt with it doing our modeling on one-to-one. So as long as the model is in a one-to-one environment, the moving it over to U.S. feet is not that big of a deal. As long as you go forward with the Revit model as a one-to-one. Does that make sense?
I think so. And I'll tell you from an API standpoint, because we have to get U.S. survey feet into Revit from programmatically as well on our end, and there's just a conversion. Everything internally is stored inside of Revit, whether you're working in meters or feet or whatever. Everything internally is stored in meters, and so. Yeah, once it's, did I say meters or feet? Everything inside of Revit is actually stored in feet, and so we do a conversion there, but it can display the other units. But internally, it keeps track of everything as feet. Here's a question for both of you guys. And I'd like to get the answers from both of you. How do you charge your projects? Is it based on the size of the building, the LOD? I mean, what goes into it, and how do you figure out how to charge for your projects?
I'll take this one first. For the field scanning operations, we charge according to the time it'll take to complete the field activities. So that's one charge at a crew rate, and again, that's based on the complexity of the facility, whether you're talking a wide open facility, compartmentalized facility, whether it's a factory or whatnot. Got enough experience to kind of know how long it's going to take, and then we charge for the office processing time. that gets you a finished point cloud. And then for our modeling, we typically lump sum that based on the level of development that the client is, that we work with the client to come up with. And that's based on a lump sum. As long as we can define that clearly in the beginning, we feel pretty confident going forward with a lump sum in that price.
So it all boils down to your estimated time.
Estimated time, yep. And if we travel, then we just bill those travel expenses as a separate line item and submit for reimbursement. That's for the field activities.
Okay.
Yeah.
Okay.
Our process isn't dissimilar. It depends on the size of the facility, but usually we approach it with a very similar kind of, how much time is going to take us to conduct the work. Modeling kind of goes on a square footage, and then base rate, and then order of complexity factor that we put into each of those disciplines, whether it's going to be purely an architectural model or if it involves MEP systems, and then we apply that that multiplier to kind of our base scale for the order of complexity. Then we put that in a lump sum.
Okay. Okay. Fantastic. This next question is directed towards me. Actually, there are two that are very similar, talking about crooked or wavy walls as well as deformed steel beams and how Edgewise handles those. And in truth, Edgewise is made, the design intent of Edgewise is to, I guess, capture the design intent of the building. And so it does not model every wave or undulation in a wall or plane. It tries to extract it as a single best fit surface or I-beam or wall. And sometimes that's not what you need. There are instances where you really need to catch the wavy nature of it, and that's Edgewise is not the appropriate tool. The appropriate tool for that would be some sort of a meshing piece of software or something that could capture that undulation. It does, however, have a QA tool to let you see for the walls, for instance. You can see a heat map and see very clearly where the wall is deforming out of tolerance. So you can see that, but it does not model that for you. Mike Path, this question is for you, I believe. The Hercules tripod, or I'm sorry, Mark, who is using the Hercules tripod? The question is, how well did it work and how much does it cost?
The Hercules tripod comes in a variety of sizes, actually. I think the tripod itself is, I want to say it's right about 1,800. And then we've got a rolling casters array on ours that allows us to, roll it basically across the site. And I think that's altogether. I think with the dolly portion of it, I think goes right at 2,500. And then you can get other extensions to extend the range of the elevator on it. So it's in that ballpark.
Okay. Okay. And then for both of you, I'd like to kind of ask kind of a final question here. Single best piece of advice for somebody doing their very first as-built. If one of you can answer for best piece of advice for what to do in the field, and the second person can answer best piece of advice, most valuable piece of advice for the office side of things, modeling out what you've captured.
I'll take the modeling one. As I mentioned in my presentation, it really defining that level of development in your deliverable is essential for both the owner and the service provider understanding that and defining that at the beginning. And again, I reference those resources in there. I think those are a great place to start to help develop that. That would be my tip of the day.
Yeah, as far as the field activities, if I were to give any advice, it's coordinate as well as you can with your client. Ask those questions that give it some time on what you're trying to accomplish and what possible constraints that aren't being displayed to you at that time or realized. There's always that sort of scenario pop up, and so it's the more thinking that you do about the project and planning, the better off it'll all come out at the end of the day.
Makes sense. Well, thank you. And Kevin Corbally, you want to wrap it up?
Absolutely. Thanks, Kevin Williams, and thanks to Mike and Mark. And we are out of time. We went a few minutes over, but I think it was well worth it. On behalf of our panelists and our sponsors, Workflow 4.0 and ClearEdge 3D, let me thank all of you in the audience for joining us today. It was just a huge number of attendees. And quick reminder, you'll be receiving an email after the broadcast with a link to the recording and a chance to subscribe to the newsletter. And there'll be other follow-up information as well. And we hope to see you again for our next webinar. Thanks for joining us.